security. This video is about Java 9 network programming security, and generally when we are talking about network programming security, then mainly we are talking about web application security. And security ensures that the application properly works, performs its function, and it is not abused or hacked. There is another thing, application safety, that also includes other measures that protect against non-human caused incidents like blackout, hardware failure, and so on. Security, at least in this video, is not concerning that one. It is very important to understand that when we are talking about security and we are developing about application development, then security is not something that somebody can add to the application later. It has to be inherent part of the application. So when we design an application and develop an application, then we have to think about the security of this application from the very start. And it doesn't work that we just develop the application not caring about the security, and at the end of the development, say in the last sprint, we say that okay, now we modify the application so it has security. No, it will not work the way like that. When we design the security from the very start, then we have to understand that the web-based applications have many links chained together, and if we don't look at each of them very carefully, then if we miss any of them, then that weakest chain will break first. The weakest link will break first in that chain. The links in the chain are the following: network that the application runs on, routers, then the web application server or servlet container, for example Tomcat, the application, the server-side Java, and the browser-side JavaScript or WebAssembly application, because web applications usually contain two different parts, one that is running on the server and one that is running inside the browser. And that way we have to think about how we protect the server from intrusion and also how we protect our clients. And last but not least, the things that run behind the application, the database and the backend application. So let's have a look at these. What are the threats that the network can handle? First of all, it's a denial of service attack. So on the network level, we can have some countermeasures against denial of service attacks, especially if it's a distributed denial of service attack. Then the network has to be configured, the routing has to be configured so that certain areas from where the attack is coming is disconnected from the network and cannot reach our server. And then after a while, these denial of service attacks just fade out, and then the network can be configured to come back to the normal way. DNS spoofing. When somebody is hacking the DNS system and redirects part of the network, the part of the clients, to malign host and not to the original host. And then it may happen that somebody is opening a page like online banking web application, and that looks exactly like the online web application, but it's not the application of the bank itself, because somebody on the DNS system rewrote the address of the domain name for the bank. It can happen, and the network and especially the DNS server configuration have to be protected against that. And there are other network related attacks. But generally, these things have nothing to do with the developers. These are infrastructure things. These are attacks against the infrastructure, and also the countermeasures have to be done on the infrastructure level. What has to concern the developer is that when there is any network communication, then the developers and especially the DevOps who install the application, and they also need the support from the developers, have to be aware of the different communications that the application needs. If an application has a connection to a database server, then the developer has to document it so that when the application gets into production, then the infrastructure team who is responsible for the configuration of the infrastructure, but they do not know anything about the application itself because they are not developing it. They only have the information that the developers give them. So they have the information that this application needs a connection to a database so they can open a hole on the firewall, otherwise the application will not see the database. And even on the inside network, connections are usually restricted, and only those connections between different servers are allowed which are absolutely necessary for the correct functioning of the different applications. It's also very important to use encryption on the lines where it's possible. And again, this is something which is an infrastructure thing, but sometimes these things have implication on the application, and the applications have to be aware of these implications, and they have to cope with it, and they have to live with it, and they shouldn't fail just because, let's say, a connection to a server is encapsulated into a VPN encrypted channel. Let's have a look at an application server or servlet container. They have to be configured so that they serve HTTPS only and not HTTP. Because by default, most of these servers just answer any request on HTTP or HTTPS, no problem. And if somebody just mistakenly types the HTTP URL instead of the HTTPS, so instead of the secure URL, then he or she will get the answer, and during a login, the password will travel on the lines through the internet unencrypted, and that way the damage is already done. The password is revealed. And it's also very important that these application servers are configured so that they do not use SSL, they use TLS only, because SSL is already outdated. It is also very important that these application servers use proper certificate, even in the test system, because many times it's a common practice that these applications use self-signed certificates on the servers, especially in development. Although having a normal, non-self-signed but third-party signed certificate doesn't cost too much. The problem with the self-signed certificates is that you get used to it. And when you open a page and it's self-signed, and you open pages many times with self-signed certificates, then the browser warns you that this certificate cannot be verified. And you just get used to it and click OK, I don't mind. And after that, if it becomes a habit, and you open a page on a server which does not have a self-signed certificate, or has a self-signed certificate because it was hacked, you will not recognize it. You will just click, OK, I know it, because it's a habit. And you do not recognize that something is out of line, something is not OK. Therefore, I recommend to always use a proper certificate, even in development. These servers should be configured to use SHA-2 hash code, hash function, or fingerprint, because SHA-1 is outdated as of 2018, this year. It is usually custom if somebody is careful enough to obscure the header information. The servers usually answer and insert some information about themselves into the header of the HTTPS responses. And this header gives the information what kind of server is answering. Sometimes it's good when we are debugging something and we should know what type of server is on the other side. But also it's a lot of information that can help a potential hacker to intrude our system. It's also a good advice, at least in production, to configure the server so that the directories are accessible and the access control is as strict as possible. So for example, if there is a web application and there is a webinf directory that contains the class files, and the Tomcat is running under a specific user, which is usually named, well, obviously Tomcat, then the Tomcat user shouldn't have write access to the directory, because it doesn't need to write anything into the webinf directory. It needs to read the class files so that the class loader can load them, but the servlet user doesn't write this directory. But if it's writable and the server is hacked, and somebody is capable through the hacking inject some code that can be executed as a Tomcat user, then the Tomcat user could write things into these directories, injecting more code or doing some harm. And that way, also the Tomcat server should not be allowed to read something which it shouldn't read. And also, it's very important that server should not run as root. It should run as a specific service user. typically it's Tomcat. Because if the server process runs as root, then there is no way to restrict the access of this process to different parts of the server. It's also important to protect against overload. So if the server is getting too many hits and it cannot handle that, then the server shouldn't try to struggle to serve these requests above the capacity of the server. So the server can handle, and we tested it, let's say 400 concurrent hits at a time. Then we should have something like 10 threads separate, that when number 401, number 402 request comes in, then the server can be configured not to serve these requests, but instead of just sending back HTTP 500. And it's a very easy to do. It's just the bouncer standing at the door and telling you cannot come in. And when somebody goes out, so there is space to serve another request, then somebody who comes at that point can come in and will be served. And the servers can behave like that, and they can be configured like that, and it has to be configured like that for security reasons. And it's very important that it's not just that somebody configures it or you configure it and then we are ready. No, we are not ready. We have to check that it's always configured the way like that. Because there are upgrades, we upgrade the Tomcat to a new version, so it has to be checked that it's again configured like that. It's still like that. And again, the application. Let's talk about the application. We have two parts of the application. One is running on the server, and the other one is running on the client. The application on the server can do several things related to security. For example, the server application can check the configuration. And if the configuration is not coherent, it shouldn't start. It shouldn't say something that, okay, this configuration doesn't seem absolutely okay, but I will try and do my best. Well, this is actually the best source for hacking. First, check the configuration. If it's not absolutely proper, then stop. Application should exit. It's also important that when the application uses cookies, it uses HTTP-only cookies for the purposes when these cookies shouldn't be handled by JavaScript. So if a cookie is set and in the header we send down it's HTTP only, then the JavaScript will not see these cookies. And if the JavaScript has nothing to do with it, then it shouldn't have access to it. It's again very similar to the access to the different directories. Also, it's very important that the cookies that we send down, that piece of information, are noted as secure so that the browser will not send these cookies to non-secure communication channels, even if there is HTTP connection available. Again, DOS can be, so denial of service attack, can be carried out not only on the network level, but also on the application level. So for example, somebody tries to log in many times from the same client. In that case, it's a good measure to stop after a while and not serving login requests from the same IP for a while, to slow down the hacking process and to avoid denial of service to some extent. And it's also very important to protect against SQL or other type of injections. When the data is coming from outside, and it can be the client or from some other source, we should be aware of the sources, whether this source is trusted or not. And usually external sources should not be trusted, because if we trust an external source, then we become responsible for that. And if the input coming from that source is not reliable, then it's our fault that we didn't check that. We always should check the input. The application on the server side should also protect against SQL or other type of injections. When we are using some data that comes from the outside world, whether it's the client or some other application, we have to check and validate the input. Otherwise, it may be possible that the input contains something that when we use it to connect to the database and make a command towards the database, and we make this input as a part of the command to the database, then it causes some side effect. For example, if I want to insert something into the database and I execute an insert command, which is something like insert into table name value equals, and then between the apostrophes there is the value of the input. But the input contains an apostrophe itself, then when the parser on the database reads the data, at that apostrophe will think that the input finishes there. And if the rest of the input is, let's say, a semicolon and then it says drop table, then the database will interpret that as a command itself, and then it will drop the table because the command was coming from an authoritative source, from us. So we have to check the input, and we always have to check the input, and it's possible to get such injection from sources which never imagine it's possible. There is a picture on the internet that is going around which shows car plate number, which is read by an application through cameras, speeding cameras, and then the plate number has an apostrophe at the end of the plate number and semicolon and then drop table. So even though it was coming not directly from a client input that was typed in on the keyboard, it was scanned by a camera, optically recognized characters, it still can have injection hacking in it. When we are talking about the client application part, when we write proper JavaScript or WebAssembly program, we have to check them and protect the client against cross-site scripting or cross-site request forgery and other client vulnerabilities. In this presentation, I will not go into that detail because these things deserve their own whole video, if not a whole series of tutorial. But it's very important, even if you are programming Java and only on the server side, to know that these things on the client exist. And a little bit of knowledge of these is important for the application server developers as well. Then last but not least, let's have a look at the database and backend, what security means on that side, on that level. First of all, you always have to check the authentication and authorization on the backend side, or let's say the database has to be configured that it does the proper checking and doesn't allow to access to something that the application is not allowed to do so. It's not because our application, we will not mangle the database that we are not supposed to write into, but if the application server is hacked, then it may just do anything. And if the backend or the database is not protected from the front end, it shouldn't trust the front end because it may be jeopardized. And if it doesn't protect itself and trust blindly the front-end application, the Java application itself, and in this case the front-end is the Java, and I separate UI, front-end, and the back-end. So the back-end, which can be a COBOL application or another Java application or just the database, and if it doesn't protect itself from the Java application, which is the web application, then this intrusion can propagate further to the backend and can make more data jeopardy and make more harm. And when we authenticate some requests and we try to authorize some requests, so some modification of data or some reading of some data and accessing some data, then the authentication can be either that we identify and authenticate the end user, the person from whom the initial request was coming, or we trust the web application that the end user was identified reliably and the web application itself is identified. In this case, we say that there is a technical user who is on behalf of the real user is accessing the backend. And whatever the front end does, doesn't matter, it's the backend's responsibility who owns the data to ensure data integrity and that the data is compliant and the functionality is compliant with the business requirements and how the business runs. And last but not least, we have to think about, when we are talking about security, how much we spend on security-related research, development, bug fix, and management. And we always have to keep it in balance with the probability of a security event and the cost of the event that it may cause in worst case. And the cost of the activities is usually lower at the start. So if I invest into research a little bit more, then I can save up a lot of during development. And even if I invest into security related activities during development, then I will save up a lot on fixing remaining bugs. And even when there is some security related bug, then we have to do and fix it. And many times it's much cheaper than just bearing the consequences of the security events that we are not protected against. So lastly, what should I say if you want to read something very specific things and not just an overall about security? I have to say that you have to visit the OWASP Application Security Verification Standard project, which is an ongoing thing and it always changes and follows the advantage of the technology, and the URL you can see on the screen and you can download it from there. There are a lot of documents and recommendations, and on the OWASP side you can find really security related and very valuable and good quality tools.